you very much. Good morning. Fine. So thank you very much for the attention. My name is Sá Pereira. I'm a technical sales manager for the Semiconductor group at Bühler Leybold Optics. And my aim today is to show you a different perspective of everything that we have been talking about by going deep into the devices and what makes the devices work. And I hope to, by the end of this presentation, I can show you that we are enablers of everything that you are working on. The title of my talk is the role of optical coatings and trimming innovations for augmented reality, meaning I'm going to focus a little bit on two separate types of technologies, one more related to coating, one more relating to trimming, meaning removing of materials that are after the coating, to show you a little bit of everything and touch upon different aspects of what is being used today in augmented reality devices. But a little bit about the company first. So Leybold Optics is a part of Bühler, and we are a company that is providing our customers with equipment for optical coatings. In a very general way, there's a substrate, we embed the substrate, or we functionalize the substrate with a coating, be that a filter, be that a single layer, be that any kind of material that needs to be deposited. And depending on the type of applications, we might have simpler applications or more robust applications. So we divide ourselves into different types of market segments, going from, for example, ophthalmic applications, traditional ophthalmic applications, all the way to precision optics, where more advanced coatings are needed on the different types of substrates. We are present all around the world. I myself come from Germany, so from the company is very close to Frankfurt. We also have an application center in the US, in North Carolina, and another one in Beijing, China. So in an application center, we have our equipment that can be used for our customers for testing and validation of their products. We are 600 employees worldwide. We have around 300 million Swiss francs. I say Swiss francs because Bühler itself is a Swiss company. And we have installed more than 3,000 systems worldwide, meaning we have a supply chain of our products worldwide for also to support our customers in case of need for parts. But going a little bit deeper into the topic. So I come from the Semiconductor group at Leybold, and here we actually see augmented reality and the coatings on AR as a semiconductor application. But in reality, this is optics meeting semiconductor. And why do we say that? Because we need to provide the optics, but we need to provide them with a semiconductor level precision, meaning automation, meaning all sorts of communication with the fab. So we combine these two worlds, and we see basically augmented reality as the combination of those two. And here are just listed four different groups of items where we're focusing on and where we see that semiconductor and optics are merging together. First of all, the optics itself, so the waveguide, the high field of view, the prescription, all of this is precision optics. So the need for optical coatings and the need for precision on the systems is very, very high. Second of all, we have the display performance, which is key. We've heard a lot of talks about different types of displays. We've heard a lot of talks about micro LED, and here it's still the winner is still not clear. So there, the performance, the power, everything here is important and needs to be optimized. And there, optical coatings also play a role. The sensing itself is a semiconductor stack. Why do I say that? Because, for example, ambient light sensors, which are also used in AR glasses, are built directly on CMOS, and they have optical coatings embedded on these chips. And then the system co-design, so it is mandatory. So basically, putting all of this together and mass production is also very important. Here in this slide, it shows a little bit our product portfolio, and of course, I'm going to focus more on the augmented reality side, but I also highlighted a little bit of the different parts that we are focusing on, such as the ambient light sensors, micro LEDs, LCOS. All of this we divided a little bit differently in our